Good morning, class. Today we are going to do two numericals on unit number 3, lateral earth pressure. So, firstly, this is 10th numerical we are doing. So, kindly have a look. Soil is having following properties. Cohesion equals to C equals to 9 kilonewton per meter square. Angle of internal friction phi equals to 20 degree. Unit weight equals to gamma equals to 18 kilonewton per meter cube. Calculate the critical depth of vertical excavation that can be made in soil without any lateral support. The ground carries a surcharge load of 3 kilonewton per meter cube. So what is given in this problem? Cohesion is given to you as 9 kilonewton per meter square, phi internal friction angle 20 degree, unit weight gamma equals to 18 kilonewton per meter cube. So what is asked? Calculate the critical depth of vertical excavation. Okay, so we have to calculate the critical excavation if it carries a surcharge load of 3 kilonewton per meter cube. If there is certain surcharge loading, then you have to calculate the critical depth. So here the formula given is critical depth or critical height HC equals to 4C upon gamma into 10 phi, where 10 phi or alpha. Okay, so alpha is given to you as 45 plus 5 by 2. So that's why here you can see that this is 4. C you have already given as 9. Gamma 18 is given to you. 10 alpha. Alpha is 45 plus 5 by 2, where phi is given to you as 20 degree. Kindly have a look. And the answer is 1.428 meter. Please go through the problem first and we'll start with the second numerical. So from this problem, there is only one formula, HC equals to 4C upon gamma into 10 alpha. All the values are given to you. So put the values and get the answer. So your critical depth or critical height is 1.428 meter. Now next 11 numerical, draw the active earth pressure distribution for a 3-layered backfill behind a 15-meter high retaining wall with a smooth vertical back. See, in this problem you have given 3 meters of equal heights. There are 3 layers. Layer 1 H1 equals to 5 meter, H2 equals to 5 meter, and H3 equals to 5 meter. So there are layers 1, 2, and 3. So for layer 1, gamma, C, and phi are 20, 0, and 35. And for layer 2, gamma is 18, C is 20, and phi is 25. And layer 3, gamma is 16, C is 35, and phi is 0. What can we observe from these given values? If you can see particularly here, when the cohesion is increasing, when your cohesion is increasing, your phi is decreasing. And here also unit weight is also decreasing. That means when C5 soil is there, there are certain values, but when cohesion is 0, that means phi is 35, that means it is a totally cohesionless soil, but there can be some amount of cohesion there. Then 20 and 25 moderate C5 soil, and here C is maximum and phi is there, that means the soil is totally cohesive soil. So let us do the numerical. So when the values are given to you, in first condition gamma is 20, C is 0 and phi is 35. When C is 0, there will no negative diagram will be there. Okay. So here you are having only soil weight here. There is no surcharge loading at the top given in the problem. So if there is only soil here, so your diagram will be only a right angle triangle. Okay, for height h1 equals to 5 meter. Now when there is a second layer, this soil load will be carried on this second layer. So here there will be a UDL developed, which is a surcharge loading of layer 1 of 5 meter. We have termed it as Q1. So it is having gamma equals to 18, phi equals to 20, and C equals to 20, and phi equals to 25. So for this surcharge loading of this layer 1, you will have to draw a rectangular diagram. For surcharge loading, we already know that we have to draw a rectangular diagram, plus there will be a soil diagram. Now there is C present here, so you will have a negative diagram. So there will be like this, negative as well as positive diagram here. Okay. Next, this layer and this layer, both the layers will have the loading on this third layer top position, which is you have to draw a UDL and you will have the loading Q2. So for gamma equals to 16, C equals to 35 and phi equals to 0. So for this UDL, you are again having a rectangular loading, and you will have a C5 soil. So you will have C is present here. So you will have here also a negative diagram. So this is your first diagram. So here there is no surcharge loading given in the numerical. So there will be only a right angle triangle. Then first layer loading is on the top head of the second layer, which you have to draw a UDL, and that is Q1. The Q1 is given by the gamma 1 and H1. Okay. Then there will be a second layer. Second layer is having C, and this surcharge loading of first layer will have a rectangular diagram, and C is present, so you will have negative as well as positive diagram. Then this first layer and second layer both will have a loading on the top of the third layer, which is Q2. So Q2 will be Q1 plus gamma 2 into H2, and again you will have third layer a rectangular loading for this surcharge Q2, and there will be negative and positive diagram. Let us see how the forces are calculated. So here there are 3 layers. So you have to calculate the 3 coefficient of frictions, Ka1, which is given 1 minus sine phi 1 upon 1 plus sine phi 1. Phi 1 is 35 degrees. Here we have phi equals to 35 degrees. So phi 1 equals to 35 degree, 1 minus sine phi and 1 plus sine 35 degree, which is coming to you as 0.27. QA2 for layer 2, 1 minus sine phi 2 upon 1 plus sine phi 2. So sine phi 2 is 25 degree. So 1 minus 25 sine 25 degree. upon 1 plus sine 25, which is coming to you as 0.4. And coefficient of active earth pressure for third layer is 1 minus sine phi 3 upon 1 plus sine phi 3. So phi in third layer is 0. So 1 minus sine 0 upon 1 plus sine 0 equals to 1. Here you have to calculate alpha also. So alpha 1 equals to 45 plus phi 1 upon 2, which is 45 plus 35 upon 2 equals to 62.5. Next is alpha 2 equals to 45 plus 5 by 2 equal to 45 plus 25 upon 2, which is coming to you as 57.5. Alpha 3 equals to 45 plus phi 3 upon 2 equals to 45 plus 0 upon 2 will give you 45 here. So here we have calculated passive earth pressure coefficient Ka1, active earth pressure coefficient Ka1, active earth pressure coefficient Ka2 for second layer, and active earth pressure coefficient Ka3 for third layer. Alpha 1 for first layer, alpha 2 for second layer, and alpha 3 for third layer. So these are your third layers. H1 equals to 5 meter, H2 equals to 5 meter, and H3 equals to 5 meter. So for first layer, we are having a diagram as right angle triangle. So here there are two layers again. The base of this layer is Ka1 gamma 1 H1. As there is no surcharge loading, there will be no rectangular diagram. So force P1 will be right angle triangle area 1/2 base into height. So 1/2 Ka1 gamma 1 H1 into height is H1. So 1 by 2 Ka1 is 0.27, gamma is 20 into height H1 is 5. So 5 into 5. Again the answer is coming to you as 67.5 kilonewton per meter. So this is the force for first diagram. So where it is acting? It is acting at Z1 from the base of third layer. So how you will calculate it? So this force is acting from first layer. It is acting as H by 3 from base of first layer. So it will be H1 upon 3 plus H2 plus H3. So it will be 5 by 3 plus H2 is 5 and again H3 is 5. So answer is coming to you as 11.66 meters. Okay. So this is the force P1 for first diagram of first layer. Now let's see the second one. Okay. So here you are drawing the second layer. So second layer is having gamma 18, C20 and phi 25. H2 is 5 meter and H3 is again 5 meter. It is having a surcharge loading of first layer as Q1, which is calculated as gamma 1 H1. So here for this surcharge loading, you will have a rectangular diagram of base Ka2 into Q1 plus there will be one negative diagram and there will be one positive diagram. For negative diagram, the formula is -2 C2 cot alpha 2, and for positive diagram gamma 2 H2 cot square alpha 2 minus C2 C2 cot alpha 2. So this is the pressure distribution diagram for two areas, negative and positive. But we want only positive diagram. for calculation. So we are adding these two diagrams and getting only one diagram. So minus 2 C2 cot alpha 2 is given as minus 25.48, and here Ka2 Q1 is coming something. So this Ka2 Q1 minus 25.48 will give you 14 positive 14.52. Okay. So second is gamma 2H2 cot square alpha 2 minus 2C2 cot alpha 2. So that is as 18 is your gamma 2 into H2 is 5. 10 square alpha 2 we have calculated 57.5 minus 2 into 20 is your gamma. So that will be 10 square 57.5, which is coming to you as 11.04. Okay. A2 equals to A2 means now positive diagram. Again, what you have to do, you have to calculate this. So this, if you calculate, so you are getting 11.04. So Ka2 Q1 minus 11.04 will give you 51.04. So all is positive diagram. Here you are getting the diagram like this. It is one vertical line, then horizontal line, then positive line. Okay, ये हमारा diagram बन गया. To make it more clear for calculations, this dotted line we draw and we make two diagrams, one rectangle and one triangle. So that is second and third. So positively second area P2 is given by base into height, as it is a rectangle. So base is 14.52 into H2 is 5. So the answer is coming to you as 72.6 kilonewton per meter. Now Z2. Where is Z2? It is acting, this is your third layer. So it is acting from third base of the third layer to the center of your rectangle. So center of the rectangle from second layer is H2 by 2 plus 3. It is not 32, it is 2. So H2 by 2 plus H3 will be 5 upon 2 plus 5 equals to 7.5 meters. So area 3. So third is your right angle triangle. So it is given as 1/2 base into height. So 1/2 into your base 51.404 minus 14.52 will give you 36.5. So 36.5 into 5 equal to 163.69 is your answer for area 3. And Z3, so Z3 is acting at the center of this right angle triangle. This is your H by 3 and plus H3. So that will be H2 upon 3 plus H3 equals to 5 upon 3 plus 5 is 6.67 meters. So this is how we calculate forces P2 and P3 as area 2 and area 3 for layer number 2. Now we are going to calculate for layer number 3. So this is your layer number 3. So layer number 3 is H3 is again 5 meter. You are having the surcharge loading Q2. Q2 is given by Q1 plus gamma 2 into H2 soil with respect to the height. So Q2 equals to gamma 1 H1, that is Q1 plus gamma 2 H2. That is coming to you as 100 plus 90. So this is your positive diagram for surcharge loading, and you are having again negative and positive diagram. So when we do the addition, you get such type of a diagram. You get such type of a diagram here. ठीक है? So for calculation of our mathematics, we just this dotted line is drawn and we make two diagrams, 4 and 5. One is rectangle and another is right angle triangle. So here the base is Ka3, Q3, and here the base for this base is gamma 3 H3 cot square alpha 3 minus 2C cot alpha 3, and here the base is minus 2C cot alpha 3. So let us see what it is coming.